This example is very similar to one of your homework problems. In this video, I will prove the base case. In the next video, I will prove the inductive step. So the assumption is that we have a function from the real numbers to the real numbers that has this special property in the blue box. And really this property just says that f of x plus y is the same as f of x plus f of y. Now this we get to assume is true no matter what. And the thing we want to prove by induction is the thing in the green box. So now first let me prove the base case. All right, so the base case, now off to the side here, I'm just going to first let's just talk about what we're trying to do. Right, the base case, we're trying to prove it for all n in the natural numbers. The first natural number is n equals 0. So we're trying to prove this thing in the green box for n equals 0. So that's f of in x equals n times f of x. Okay, well if n is 0, this is really trying to say that f of 0 times x is equal to 0 times f of x. Okay, so that's what we're actually trying to prove. And we're proving the base case is that right there. All right, so now the way to do this, so the reason that we have this example is because I want you to see that sometimes the base case is more difficult to prove. And this is a problem that's accessible to Math 189, where the base case is actually harder to prove than just a one sort of identity. All right. So in the proof of the base case, what we're going to do is first we're going to prove, so we're first going to prove that f of 0 equals 0. Once we know that f of 0 equals 0, then this follows from that. Okay, so let's just for a second here, let's assume that I've already proved that f of 0 equals 0. Okay, if I know this is true, then let's see, how can I use that? Okay, so f of 0 times x, that's this part, is equal, well 0 times x we know is 0, that's f of 0, which is from this right here is 0. Okay, now what's 0 is equal to 0 times anything, right? So 0 times f of x. Okay, so if we can establish that f of 0 equals 0, then the last line of our proof of the base case will be so, and that. All right, so now let's establish that f of 0 equals 0. And to do this, we're going to have to use the special property. Otherwise, the special property wouldn't have been included in the example. All right, so f of x is equal to f of x plus 0. Now using this property, right, notice the property is true for all x and y in the real numbers. So certainly y is a real number. So we know that this property works, so this is equal to f of x plus f of 0. Okay, now we'll subtract f of x from both sides. So f of 0 is equal to f of x minus f of x, which is equal to 0. Okay, and so now I've proven that f of 0 equals 0. Maybe I want to just write it in. Say, so f of 0 equals 0. Right, that's the proof of the base case.